Okay, so we're going to be factoring today. So the first thing that you always look for is a GCF, which is the greatest common factor. It's the greatest number or terms that can go into all of your terms that you have on your polynomial. Okay, so it says look for the GCF first. If the first term is negative, factor out a -1. So first thing, look at your numbers on number 1. Okay, so they have a 3 and a 6. So the greatest number that will go into both of those is a 3. And then you have an x squared and an x. That means you have 2 x's and you have 1 x. Okay, they both have 1 x in common. So you're going to take out a 3x. 3x would be your GCF of this polynomial. Okay, so when we take out a 3x, to determine what's left, you're going to be dividing each one of those terms by your GCF. So 3x squared divided by 3x would give you x. 6x divided by 3x is a positive 2. When you distribute that, it should end up giving you back the 3x squared plus 6x. So when you're factoring, it's just writing it a different way. They should be still equal. Okay? So that's all we would have to do here is just take out the GCF, the greatest common factor. Okay, so looking at number 2. First, look at the numbers. So we have 25 and 30. The greatest number that would go into both of those is 5. And then you have a y cubed and a y squared. Y cubed means that it's y times y times y. Y squared is y times y. So they both have 2 in common. So if they both have that variable in common, you're always taking out whatever that smallest one is that you have, which would be y squared. So 5y squared would be your GCF. You're going to divide each one by whatever that GCF is. So you'd be left with 5y minus 6. If you were to distribute, you should end up getting 25y cubed minus 30y squared. Okay? All right, so let's take a look at number 3. Notice that first term is negative, so I'm going to go ahead and put a negative here. Anytime the first term is negative, you want to factor a negative out. So look at your numbers, 6, 4, and 8. The greatest number that will go into all 3 is a 2. So we're going to take out a -2. Notice here that we have an x cubed and x squared, but there's not an x term here. You can't factor it out if they all do not have it in common. So we're only going to take out a -2, which means I'll divide each one by -2. So you would be left with 3x cubed plus 2x squared minus 4. When you distribute the -2, you should end up getting the same polynomial that you started with. Okay, looking at number 4, notice the first term is negative, so go ahead and put a negative there. We have a 6, a 15, and 11. There is not anything that will go into all 3 besides a 1. Since the first term is negative, I'm going to take out a -1. So really all that does is it changes the sign of each term. So that would be 6x squared minus 15x minus 11. And that's all we really need to do here. So if the first term is negative, always factor out a negative. If they don't have anything in common besides a 1, you'll factor out a -1. Okay, so that's the first thing that we always look for is GCF. The next step, we're going to be looking at examples that only have 2 terms. When you only have 2 terms, you need to check for difference of squares. Difference means subtraction. Squares mean perfect square numbers. So for example, whenever you take a number and times it by itself, that answer would be a perfect square. So 1 times 1 is 1, so 1 would be a perfect square. 2 times 2 is 4, so 4 would be a perfect square. 3 times 3 is 9, 9 would be a perfect square. So those are perfect squares. So if you have difference of squares, you will factor it by taking the square root of each term, and then you'll put those as factors. So let's look at this first example here. First, check. They don't have anything in common, okay? So you're going to look at, make sure that you're subtracting. So we are subtracting. And then check for perfect squares. X squared, we can have a term multiply by itself to give us x squared. That would be x. 9, 9's a perfect square, okay, because 3 times 3 would give us 9. So anytime you have difference of two perfect squares, you should open up two different sets of parentheses. We're going to take the square root of x squared, which is x. So if you multiply those together, you should get x squared. Take the square root of 9, which is 3. When you multiply those, you should get 9. Now notice we want negative 9, so one of your factors will be positive, the other one will be negative. If you were to multiply these together like we did yesterday, you should end up getting x squared minus 9. Okay? So again, when you're factoring, you're just rewriting it a different way. It should still be equal. So if you were to multiply, it should give you back the x squared minus 9. Okay, number 6. Notice we have two terms. They don't have anything in common. We are subtracting, so we need to check for perfect squares. 4 is a perfect square. X squared is a perfect square, and so is y squared. So this would be difference of squares. So open up your two sets of parentheses. Take the square root of 4x squared, which is 2x. And then the square root of y squared is y. You should have one as a plus and one as a minus. When you use FOIL here, if you use FOIL like we were talking about yesterday, you should end up getting 4x squared minus y squared once you combine like terms. Okay? So you can always check once you factored, multiply them back together. It should give you that original that you started with. Okay, number 7. Two terms. They don't have anything in common, so we're checking for difference. We are subtracting of two perfect squares. 25 is a perfect square. 49 is a perfect square, and so is x squared and y squared. So this is difference of squares. When you take the square root of 25x squared, you get 5x. So if you were to multiply those two together, you would end up getting 25x squared. The square root of 49y squared would be 7y. You should be adding and subtracting. Again, you can check that by using FOIL. Multiply it, combine like terms, you should end up getting 25x squared minus 49y squared. Okay, so let's take a look at 8. 5x squared minus 12. Notice they don't have anything in common. We're checking for difference of squares. We are subtracting. X squared is a perfect square, but notice 5 and 12 are not two perfect squares. Okay, so if you have two terms and they don't have anything in common, and they're not difference of squares here, then it will not be factorable. So you do write prime. So that was not difference of squares. So your answer would be prime. So anytime you cannot do anything with your problem, you can't factor it, then it's prime. Okay, looking at example 9, x squared plus 9. We're checking for difference. Notice difference is subtraction, this is subtraction, this is plus, so that's sum. The only thing it says up here is difference of squares, it works that way. So not sum of squares. X squared and 9 are perfect squares, but that's the sum. You will not be able to factor this. This is prime. Because it's sum of two perfect squares. It has to be the difference. If you had wrote x plus 3 times x plus 3, just taking the square root of each one, then you would have ended up with x squared plus 6x plus 9, and that's not what we started with. Okay, so sum of two perfect squares cannot be factored. So we write prime there. Okay, looking at 10, 169x squared minus 100. We are subtracting. 169 is a perfect square, so is 100. So this would be difference of squares. Take the square root of 169x squared, which is 13x. Square root of 100 is 10. Remember, we add one, subtract the other in order to get that negative 100 there when we were multiplying it together. So you should be able to use FOIL here, and it should give you back your original polynomial that you started with. Okay, so that was dealing with 2 terms. Now we're going to look at 3 terms. If there are 3 terms and the number in front of x squared is a 1, you can factor it mentally. So notice this number in front of x squared is a 1. To factor it mentally, we're going to figure out what 2 numbers will add to the middle number, 15, and multiply to the outside number, which is 36, for that last term. All right, if you can't figure that out in your head, write all the factors of 36. Start with a 1. 1 times 36. Those will not add to 15, so keep going. Go to 2. 2 will go into 36 18 times. 2 plus 18 does not give me 15, so keep going. 3 will go into 36 12 times. 3 plus 12 does equal 15. So we found the 2 numbers that would add to 15 multiply to 36. When you're factoring it, you'll have 2 sets of parentheses. We want that first term to be x squared, so we would need an x on the first terms of each factor. And then we found it to be positive 3, positive 12. So this looks similar to what we had yesterday. We were given this, and we came up with this when we were multiplying. Remember, we did that mentally. We added these 2 to get the middle, multiplied to get that last one. Okay, so it's the opposite of what we were doing yesterday. So you should be able to multiply these together, and you should end up getting that original polynomial. Okay, so notice we have 3 terms again on number 12, and that number in front of x squared is a 1. So we want to add to negative 9, multiply to positive 14. If you're wanting to add to get a negative and multiply to get a positive, that means both of the numbers would have to be negative. So that would be negative 2 and negative 7. If you can't do it in your head, write all of the factors out. So that would be x minus 2 and x minus 7. It doesn't matter the order that you write these as long as it's the correct sign. So you could have x minus 7 times x minus 2. That would give you the same answer. Okay? All right, looking at 13. We have 3 terms again. Number in front of x squared is a 1. So we want to add to the middle number 9, multiply to the outside numbers, which is negative 22. Since we're adding to get a positive, multiplying to get a negative, that means only one of them needs to be negative. So negative 1 times 22, that does not add to positive 9. You go to the next one, negative 2 times 11. Notice when you do add those, it gives you a positive 9 there. So we would have x minus 2 times x plus 11. If you multiply them, you should end up getting x squared plus 9x minus 22. Okay, the last one in this section, 3 terms again, adding to the middle number, negative 5, multiplying to your outside number, which is negative 14. Since we're adding to get a negative, multiplying to get a negative, only one of them needs to be negative. So that would be negative 7 and positive 2. Because you want to add to get a negative, which means the larger number would need to be the negative one, which is 7. So that would be x minus 7, x plus 2. Same thing on all of these. It doesn't matter the order that you write these as long as it's x plus 2, x minus 7. So the sign has to be correct for each factor. Okay, the next part, we're going to factor each of the following completely, which means we're going to keep factoring until we cannot factor anymore. The very first thing that we check for when we're factoring is the greatest common factor, the GCF. If they have something in common, you need to take that out before you do anything else, okay? So looking at 15, 3x squared plus 24x plus 45. Notice those all three have a number in common. The greatest common factor here would be a 3. Notice they don't all three have an x, so we're only going to take a 3 out. So dividing each one by the GCF, we end up with x squared plus 8x plus 15. Once you take out the GCF, you need to look and see if you can factor what's inside the parentheses. Notice we have 3 terms, so we just went over the 3 terms at the top. This is a 1. We want to see if we have anything that adds to 8, multiplies to 15. So that would be 3 and 5. So that would be x plus 3 and x plus 5. Now, if we put this as our answer, remember I said factoring, you're just rewriting it a different way. So if you were to multiply these two together, you wouldn't end up with your original. So make sure if you take out a GCF, make sure that GCF should be in front on your answer. Okay, so that way if you were to multiply them all through, you should get the original there. To multiply them through, you can multiply this one times this, get an answer, and then use FOIL to multiply it by that third one. Excuse me. Okay, 16. Notice the first term's negative, so I know I'm going to factor out a negative. Then look to see if you have a GCF. 5, 50, and 120. The greatest number that will go into all three is a 5. Notice we have an x squared, and x. They all have that variable in common. Remember I told you, if they all have the variable in common, you're always going to factor out the smallest one. The smallest one would just be an x. So we're going to divide each one by negative 5x. So you would be left with x squared. That would be minus 10x. And that would be plus 24. Okay, so after we take the GCF out, when you look inside, we have 3 terms. We need to see if we can factor that. Coefficient of the x squared is a 1. I'm going to see if there's anything that adds to negative 10, multiplies to positive 24. We went over this earlier. If you're adding to get a negative, multiplying to get a positive, they both would have to be negative. So that would be negative 4 and negative 6. If you can't figure it out, just write all the multiples of 24. Make sure to remember to bring down that GCF, the negative 5x that you took out at the beginning. Okay, let's look at 17. 125x squared minus 80. I'm going to find the greatest number that will go into both, and that would be 5. Notice that x squared, we don't have an x here, so we can't take an x out if they don't all have it in common. So I'm going to divide each one by 5. That would be 25x squared minus 16. Then look on the inside. Notice we have 2 terms this time. When we went over 2 terms today, we were looking for difference of squares. So we are subtracting. 25 is a perfect square, so is 16. Bring my GCF down. Open up my 2 sets of parentheses. Remember, on difference of squares, you're going to take the square root of both terms. So square root of 25x squared would be 5x. Square root of 16 is 4. I'm going to add 1 and then subtract the other. You should be able to multiply them all together, and it should equal 125x squared minus 80. Don't forget to bring your GCF down. Okay, this last one, notice the first term's negative, so I'm automatically now I'm going to take a negative out. 3x cubed minus 12x squared. The GCF number would be 3, because that's the greatest number that will go into both of those. Since we have an x cubed and an x squared, remember I told you if you have variables in common, it's always the smallest one that you'll take out. So we'll take out an x squared. So you would, when you're dividing it by the GCF, you would have x plus 4. Inside the parentheses, we have 2 terms. That is not difference of squares, so that would be as far as you can go.